Okay, we can start it here. If you haven't already, please scan the QR code. Welcome to Swamp Launch Rocket Team's first GBM of the spring 2021 semester. Yeah. Okay, let Adam from IREC start.
Okay, so basically for any new members, I'm just going to go over what the IREC team is doing. So basically we compete in a competition called the Spaceport America Cup that takes place every year in New Mexico. Basically, the objective of the competition is to design and manufacture a rocket that goes to 10,000 feet on a solid propellant while trying to innovate some cool payloads. So we've been working on two cool payloads for the past year and a half now. The first is the drift control system, and second is the altitude control system. You'll learn more about those later. Right now, our main thing is that we're in full manufacturing mode. So we have lab access in MAEC, the mech design lab, every night at 6:30. We're usually in there doing stuff with the rocket. So if you ever feel like you want to come out and participate in that, feel free to. Just make sure you let one of the leads know beforehand, because we do have capacity requirements. And then the next big thing that we're trying to push for is we want more sub team members to join onto the sub teams and help out with technical stuff, as well as the report that is going to be coming up in the competition. So I'll pass it on to the leads now to talk more about their individual sub teams.
Hi, I'm Gavin. I took over the role of structures lead last semester, and when we started getting in the lab, we were able to put the fins on the rocket and get the aft section it's pretty much ready to go. We're just waiting to do the final coats till we finished all the processing on it. The next big objective for structures is to do a custom carbon fiber layup for the main body section, which I'll be finishing the work that the last structures lead was doing, and he made a custom jig to make that carbon fiber tube. Unfortunately, the access to that is going to be kind of limited, but if you want to know anything about the carbon and what we're doing, feel free to reach out and I'd be happy to inform you on it. But so the main structure of the rocket's pretty far along and we're doing pretty good. We should be done with it. We're aiming to be done by March 1st, but we should be done in the next couple weeks. That's all for me.
Hey guys, my name is Bilal. I'm the flight dynamics lead. So just to review our mission. So our task is to hit a target altitude of 10,000 feet, and we lose points for being above and below that. So the goal is really to hit that target altitude. So what we're trying to develop is a system so that we can basically slow the rocket down as it approaches apogee. So you can see in the diagram, when it's in coasting flight, we want to somehow stop the rocket mid-flight so that it can hit, instead of going over the apogee, it just hits perfectly 10,000 feet. So what we're doing is we're developing a payload that we're going to use SolidWorks, MATLAB, and ANSYS together to basically achieve that. And I'll show you a diagram of the payload in the next slide. So yeah, as you can see, as the rocket approaches 10,000 feet, it's going to deploy those little fins on the side using a computer. That's basically has like the current like position, velocity, angle, and it's all going to calculate on board by itself without any user input when to deploy those fins and slow down the rocket. So just to go over what we're doing right now. Right now, I'm working on the SolidWorks model and trying to get a prototype finished before February so that we can start testing the system out and maybe even like doing like kind of like some mock flights, I guess. Last year we were developing like a MATLAB code, and it doesn't necessarily have to be a MATLAB, but just a code for the rocket to know, given a velocity and a pressure or a velocity and orientation, when should I stop, or when should I deploy those fins so I could stop. And then we're using ANSYS to accurately model the drag on the rocket, so that it could be even more accurate and allow us to use more stuff. So if this sounds interesting to you, we're really looking for members who have experience or who want to learn those software. It doesn't really have to be much. Like I'm talking, you're fresh out of CAD class or you're fresh out of MATLAB class. It's a good place to start and a good place to really, learn what those programs can do and really apply them. Also, people with intro to aero experience, because this is directly related, and controls as well, because we're using an onboard computer to do it. Also, is anyone really interested in the project? I'm not gonna, flame you here for not knowing. This is definitely a good, this is a play or a good project. If you're interested, you could develop or you can put time into it, then you can really contribute something good. So that's all I got. Thank you.
And for that last subsystem, we have a new lead, Vishvak. I don't know if he wants to say any words on it or.
Hey, my name is Vishvak. I'm new here, but I guess this semester we're going to be working on a lot of electronics, making sure the ECA system works perfectly. We're going to be using the Arduino. We're going to be using a bunch of different sensors, and we're just going to learn about breadboarding in general and just making sure everything works fine.
Cool. All right. So hi, I'm Bryce, IREC Avionics and Recovery Lead. So what we have right now is basically we have the bay printed right now. So yeah, we just got to go pick up the sled. And then for the holes, basically we just need to drill some holes in those like little base plates. We've already water jetted the plates themselves. So sometime next week, probably after our individual meeting, which is on Tuesday at 7. After that meeting, we're probably going to decide on a time that week to do some drilling of holes. It'll be super easy. We'll get some experience on the machines, and if you want to come out to the lab, it's on campus, so it should be super easy to come out. And yeah, if anyone wants to come by, it'll be super fun. Even if you're like mainly SL, it's a fun little adventure. Yeah, so that's what we're doing right now. We also have to do testing with our tinder descenders because we've never used a tinder descender before. So we're probably gonna just get a long line of wire and basically blow off the tinder descenders, make sure they work, and make sure that the parachute would open if they were to work. And yeah, also last thing, we just need to program the altimeters, which is also super easy. We just have to find them. And yeah, so that's what we're up to over at Avionics Recovery. Next slide.
Hey, I'm Tyler. I'm our other payload for IREC, which is drift control. We have the basic design pretty much figured out. We've moved the bay actually to a smaller bay that'll sit inside the airframe instead of being attached to it. And right now, our biggest thing is trying to get a parachute that is structurally stable and find some details on it, how much weight it can carry, drag coefficient, stuff like that. So we're doing a quick test of a prototype for that on Saturday afternoon. And then after that, we can hopefully finalize the design in the next couple of weeks and get something manufactured for that March 1st launch date. So that's where we're at with drift control.
Yeah, if anyone wants to come out to that Saturday thing, we're just going to be basically throwing this parachute off a ledge. And it was pretty fun last time we did it. So if you want to come by, it's a fun experience.
All right, hey guys, I'm Dylan Ogrodowski. I am the NASA SL project manager. SL is the other competition we do other than IREC. These are completely separate. Our goal is to go deliver a rocket and payload up to, this year we're doing 4,500 feet. Our rocket's going to carry a payload that has to launch, and then while we descend, we have to shoot the payload out. It has to land on its own. It has to take and then transmit panoramic imagery. We're going to do a live video feed from the payload, and then it has to be able to stand itself vertically after it lands. So this is our subscale rocket that we actually just launched 3 times, I think over break, maybe a little bit earlier than that too. It took 3 flights, and Megan will let you know a little bit later about why it took 3 flights. But these were pretty exciting launches. If you want to go to the next slide. So this is our payload. Like I said before, it has to be able to stand itself up. So when you see those legs, that's what that's for. We've also got a Weeble, accelerometer, gyroscope. So it's a little bit of a control system, just like IREC is doing. If you're into electronics or really mechanics or anything, definitely check out the payload team. We're actually just getting into manufacturing starting this week. So if you want to get involved, now is a great time. I'm sure all of the sub teams would love to have new members. And right now we're just getting into manufacturing. So this is a good place to start. If you want to go to the next slide. And alongside the payload, we're also building the full scale. So how we're going to be doing this is each sub-team lead will be coordinating manufacturing times for their specific section. So if you're on the structure sub-team, you'll be working basically on cutting airframes, fins, things like that. If you're on the payload sub-team, obviously you'll be manufacturing the payload. Recovery team will be doing recovery harnesses, parachute setup, building the avionics space, everything like that. So if any of that sounds interesting to you, talk to your sub-team lead, figure out when you guys can build, and definitely get involved. I think some of the most valuable experience that you'll get on Swamp Launch Rocket Team is when you're actually in the manufacturing center building, because that's really where you're going to learn the most. So if you're new and you don't have a sub-team yet, that's perfectly fine. You can still join them. To do that, you're going to go on Slack and you're just going to join their sub-team channel, maybe send the sub-team lead a message, or if you don't want to do that, you can send me a message and I can get you some more information. So like I said, I'm Dylan Ogrodowski. Feel free to send me a message if you want to kind of get involved in the sub-team and don't know where to start. But definitely hop in, get involved. We would love to have people build with us, and we're gonna really going for it.
Okay, so we have a video of our subscale flights. Video doesn't really work well through Zoom. I can try play it real quick. It's like a minute long. Otherwise, I'll post a link to it in the Slack. Okay, so yeah, that showcased all 3 of our subscale launches. Yeah. So I think in the next slide, we'll start talking a little bit more about it.
Hi, everyone. My name is Megan Winnack. I'm the testing lead for NASA SL. So I'm going to talk a little bit about the launches that you just saw and sort of what happened in each one and kind of the testing that we did leading up to the launches, kind of bring everyone up to speed. So kind of pretty much the only testing that we did on the subscale was ejection testing. Across our 3 launches, we did a total of 10 ejection tests, and the black powder values that we used are shown there on the slide. And then of course you just saw we did the 3 subscale flights. So I'm going to kind of go over what happened for those. You can go ahead to the next slide. I'm pretty sure the next slide is one of the ejection tests. Yeah, so here's a video, a short video of one of our drogue ejection tests. You can go ahead and play it. Just so if you're unfamiliar with an ejection test, we ran these for all the different sections for the rocket and ultimately wound up getting successful ones. So that's for our drogue, determining that the 1 gram would be launched. You can go to the next slide. Okay, and then these are the other ejection tests as well for the payload and the main. You go ahead and play the payload one, because this one's cool. This one we ejected the payload weight as well to simulate the payload jettisons. You can see that happen in this one for the 2.7 gram charge. So yeah, there's that one, and you can skip the next one. I think it's just the main, which is the same as the drogue for the 2 gram test. Okay, so the first subscale flight. So the first subscale test flight, unfortunately, failed due to an improper mounting of our motor. As you can see, the motor actually tore through the aft airframe due to an issue with the forward closure. So this was not a successful flight. There was no altitude, no events happened. We were able to recover the majority of the rocket, which is awesome. We only had to reconstruct the aft bay, but we did have to launch again over break. So our first test was not successful. So that will take us to the next slide, which has our second test, which was partially successful. We did have a flight apogee, you can see on the screen, but we also had a high ground hit velocity, and that's because one of our parachutes did not inflate all the way. It wasn't wrapped completely and within the airframe. And so the heat from the charges actually kind of melted the parachute together. So it didn't open all the way, and that gave us a really high ground hit velocity. So that was not a fully successful launch either, but thankfully there was no damage. So we were able to launch again for our third flight. And that's on the next slide. So our third flight was our final and our successful flight. Apogee was at 2,410 feet. Ground hit velocity was 12 feet per second. So that was great. The payload jettisoned and landed separately the way that we hoped it would, and it was recovered with no damage. So that was our successful subscale test flight, and we were able to get that done and submitted in time. So that's awesome. And so that concludes everything we're going to be doing with the subscale. So yeah, you can go to the next slide. Right, so now that we're finished with the subscale, as far as testing goes, like Dylan said, we're going to start manufacturing our full-scale launch vehicle and our payload. So that means for testing, alongside that, we're going to be trying to run some tests as well. Very similar tests for the full-scale launch, ejection tests, and probably a little bit more structural tests as well, since we're going to have get started earlier this time, which is awesome. But also we're probably going to have a much more heavier focus on our payload testing, because that's going to involve not only structural testing, but also software and electronics and other things like that. So there's definitely going to be heavy focus on that. So that's going to be, that's kind of what testing wound up doing kind of at the end of the semester last year, and for the project overall, and what's going to be coming up. So yeah, that's all I have. Thanks.
Hey guys, so this year we're gonna accept your t-shirt design proposals. You could draw, create whatever design you want, and it could be on the front of our shirts this year. The only things I'd like you to know, if you'd like to submit a proposal, is the logo is available on the team drive, and the student government logo is on the back. So if you'd like to see your design immortalized in Rocket Team history, please submit it at that Google Forms link, or contact me or Joel on the Slack. And finally, please join us for an interdisciplinary truth detecting team exercise. We're gonna have it on Saturday, the 23rd, and I'd like to run a quick poll right now just to see if what time is best for everybody.
You need to give me. I forgot to make it. Hold on.
Yeah, I'll give you 1 second. Okay.
Yeah, Among Us was pretty fun last time. Definitely come check it out. I think we had like 7 people. It's really chill. You don't have to be good at the game. You don't have to know how to play the game.
I don't even know how. I've never installed it, so this is gonna be horrible for me. But
You
whatever.
just show up and we'll figure it out, and it's a fun time. If you wanna get to know the team or make friends, we're all online. We're all in the same boat. So hop in. It'll be fun.
Can you see my screen?
Yeah,
Am I on the Google slide?
you're not full screen though. You're still
Okay,
in like the
that's-
browser.
Okay. Poll. This one. Okay. I think I have too many people as co-hosts because you all can't vote.
Yeah, I can't vote. I'll put a vote for 6 to 7.
Well, you all can see it real time right now.
Ooh. It's like a bell curve. It's like actually oh, okay.
Okay. So it's a tiebreaker between 6 to 7. Never mind.
Ooh. We have 4 more votes left.
And then there's a bunch of leads who can't vote because they're co-hosts.
Disenfranchised.
Okay, so it'll be around this time then, or whenever Bilal.
7 to 8 is fine, yeah.
Okay.
And you can get the game for I think like $5 on Steam, or if you don't want to pay that, you can just download it on your phone for free. So it's super easy. Definitely check it out.
Okay, and then here we have all of our sub teams and when they are meeting. So yeah, a lot of them they've already been determined. I'm the structures lead. I haven't set mine yet because whenever we start our meetings for me, it's going to be manufacturing. So I'm going to send out a when to meet soon for like when we can get everybody to come out to the SDC or MAE to start with the full scale build.
And also I have a when to meet in my Slack. If you don't know where the it should be in my sub team meetings for the ACS, but if you don't see the when to meet in your Slack, let me know or DM me on Slack.
All right, and so that's our GBM this week. Next one will be in 2 weeks. Yeah, thanks for coming out. I think there was if you have any questions, just feel free to mention it in the chat. So join our Slack. That's where all of our communication takes place. And then yeah, we'll see you in 2 weeks.
Did you send out the link to Slack?
I can send it again. So that's the link to join our Slack.